Good day, good day, good day. Welcome to our YouTube page or Facebook page if you're watching from Facebook. So I want to give you a warm welcome. I hope you enjoyed this with us. So today we are on topic on measurements, which will cover grade 10 and grade 11. I hope you enjoyed this topic, and also I hope you will get full insight on this topic, right? So before we can go any further, if you haven't subscribed, can you please click that subscribe button and that follow button and also that notification button so that you won't miss anything from us. I hope we have a great time during this topic. All I want to do is that I want you to just relax, take a book, take a pen or a pencil and note down everything that I'll be telling you, so that you can use them to apply on your questions. Let's go. I hope you enjoy. So what is measurements all about? So no one can deny that we are living in a spatial world, right? So mostly we're interested in how much of the space we are having, right? How much of the space we have, right? So just imagine if you want to paint the walls of your house. If you want to paint the exterior walls of your house, right? Or maybe if you want to fill a tank. So all these, the thing that is in interest is measurement. So we are going to explore more on all these. So the paint on the wall is more about the area situation. And to fill a tank with water is all about the volume situation. But if you don't understand what is area and what is volume, don't worry, I have your back. So I'll start as further as describing what is the area and also what is the volume, so that you can enjoy this topic without a worry, right? So let's go. So before beginning this topic, these are the things that you will need. I hope you are able to convert between units. For example, moving from millimeter, centimeter, meter, kilometer, and so on. I hope you are able to do that. If you are able to do that, that's a good job. And also basic algebra. I'm sure you are able to multiply between terms. And lastly, making subject of the formula. I hope you are able to do that as well. So if you're not able to do that, can you please revisit your work? I'll also give you a link that will go to the channels that you can be working on that. So let's go on. So let's start off with the area. So what is the area? So the area is the two-dimensional space inside the boundary of a flat surface. So it is measured in units squared. For example, millimeter squared, centimeter squared, meter squared, kilometer squared, and so on, right? So we need a 2D shape in order to calculate the area. So how many 2D shapes do you know? Maybe you can do a revision on that. So we are going to deal with the area of 2D shapes like circle, square, and rectangle, and also triangle, or maybe you can also do a rhombus and a parallelogram. But these two, they're not that much of a problem, because when we're dealing with the volumes and the total surface areas, mostly we don't deal with these shapes. Mostly we deal with these shapes that will be repeating over and over again, right? So let's get to it on how to calculate the areas of these shapes. So let's carry on with the areas of these 2D shapes. So to find the area of a square, we all know that a square has all sides equal. So this side is equal to this side, equal to this side, and equals to this side. So to find the area of a square, we just say side multiplied by side, since these are equal. So it will be just side times side. So it will depend on the measurements that you are given here, right? It depends on the values that you are given. So it means that you just say side multiplied by side. That's a square. So if you are moving to a rectangle, we know that a rectangle is a shape that is more like this. So to calculate the area of a rectangle, this is our length, this is our breadth, right? So to calculate that, we just said the area of a rectangle is equal to the length multiplied by the breadth. And then a triangle is also very, very simple like that. So if you're having this height here, we call it the perpendicular height of this. So this makes 90 degrees with the ground. So this side, we call it the base. So this side, it is the base. It is where the triangle is sitting on. So if you're having the base and also we are having this height now. So it means that calculating the area of this is simple. So we just say the half of the base. So the half of this multiplied by the height. That's how we can find the area of a triangle. Now moving to a trapezium. We know that a trapezium is a shape that is having one pair that are parallel like that. It can be like that. So we can call these sides that are parallel A and B like that. And then the perpendicular height here, since we know that the height between parallel lines are always equal. So the height here, the height here, the height here, the height here will always be equal because these are parallel lines. The distance between these lines will always be equal. So to calculate the area of the trapezium, we can say just half of this side plus this side and multiplied by the height. So it's half of this side plus this side in the bracket, and then you multiply them by the height, just like that. So moving to a parallelogram. So also a parallelogram, we know that it is having two pairs of opposite sides parallel. So this is parallel to that, and this line is parallel to that. Maybe let me just show nicely here so that you can see what we are talking about. So we said a parallelogram is more like a shape that is having a pair of parallel. So these lines will be parallel, and also these lines will be parallel. So we can name this side that it is sitting on the base. And you know that the distance between parallel lines is always the same. So this is the edge. So to calculate the area of this, we just say the base multiplied by the height of this. So the base multiplied by the height, and then you can find the area of a parallelogram. And then lastly, we can move to a circle. So guys, please put this in notes, right? You can note this out because when we are dealing with the total surface area, we'll be talking so much about the areas of the shapes that are on the flat surfaces. Don't worry for now. We're going to see when we're dealing with the total surface area. So we are going to have a circle, and you know that a circle has a center, and any line passing through the center to that other side, we call that the diameter, right? So any line from the circumference to the center, that's the radius. So we also know that a diameter is equal to 2 times the radius. So if you are given the diameter, you know how to find the radius, right? We can use that, or we can say the radius is equal to half of the diameter, right? Just like that. So to calculate the area of a circle, we just say pi r squared. So pi r squared, the area becomes pi r squared, which pi we know that it is a value that is 3,142, and the change, it doesn't change this number, it remains the same. So r being the radius, we square the radius. So something else that I want you to keep in mind also is to find the circumference of a circle. And the circumference, it is the total distance around this circle. That's what you call the circumference. So to calculate the circumference, we just say circumference is equal to 2 pi r. Or if you are not having the radius, you are having the diameter, you can also say the circumference is equal to pi multiplied by the diameter, like that. So having said that, I'm sure you are able to find the areas of this. You can also check the examples that can help you to find the areas of these shapes. So I'm going to cut this video here and call it part 1, and then I'll start doing the volumes and the total surface areas, but I'll also separate the videos in terms of the section. So if you haven't subscribed, please subscribe, follow, like, and also comment. If you enjoyed, I hope you enjoyed. I enjoyed. So see you on the next part.